Lesson 6.8, determining values in a linear relation. This is a little bit of problem solving in this lesson, trying to figure out numbers that are missing and kind of just using common sense. Example 1, Janice is a piano teacher. She earns $23 an hour. She wants to earn $200. So I always imagine that this is myself. Okay, so if I made $23 an hour, I want to save up somehow and get $200. So here are 3 ways she can determine the time she has to work. So this is kind of fun, sort of not too hard. Imagine that you're at home and this is you and this is the question you have at home. Okay, I make $23 an hour. I need to make $200. One method to do this would be to make a table. So I don't know if this is something you do at home. You think, oh, I need to make a table. So you get out your pencil and you write a table. We want to see how many hours I'm going to have to work to make $200. So far, here's my table. I've kind of started this table for you. If you work 1 hour, that's $23 because she makes $23 an hour. So 2 hours, if I do 2 times 23, I get 46. So if I make $23 an hour and I work for 2 hours, I get $46. Okay, so this is common sense. You could do this. And then 3 hours, you'd get $69, and 4 hours, $92. So if we had to continue our table, what we need to do is figure out how many hours I have to work to make $200. So 5, 6, 7, I don't know how many hours right now, but let's try 5 times 23. I make $23 an hour. That's $115. If I do 6 times 23, I get $138. You might see another way to do this. This is going up $23 every time, right? We're going up $23 every time. The rate is $23 per hour. So I could also just keep adding 23. So 7 times 23, or add another 23, I get $161. Okay, I'm getting closer to my $200. 8 is $184. I'm really close now. What if I worked 9 hours? I'd have $207. So this is one way to figure this sort of question out. At home, just in day-to-day life, we try and figure this out, and okay, I'd have to work about 9 hours in order to make $200. You'd get a little bit extra, actually. But I don't think 8's enough, and 9 is a little too much, so you'd be safe to work 9 hours. Therefore, she needs to work 9 hours, and that's just kind of a rough estimate. Another way we could do this is to draw a graph. Without knowing anything except the fact that she makes $23 an hour, we could try and draw a graph. So this is just a second method. At home, you're thinking, oh, I need $200. I know, I'll draw a graph. Maybe, maybe not. I don't know if anybody would do that, but you might. Okay, I'm going to do a graph because that'll help me figure this out. So if I draw a graph and go up to 10 hours, let's say each one of these counts as 1 hour, so that'd be 2, 4, 6, 8, 10, something like that. And I can count up the side maybe by 50 every second line, so that'd be 100 here, 150, 200, 250, 300, up a little higher, you get the idea. So down along the bottom is time, that's in hours, and up the side is pay. And if I was going to graph this, I really only need 2 points. I know that if Janice is a piano teacher and she doesn't work at all, she's not going to make any money. So this demonstrates direct variation. All I need is one other point. So let's just pick. Let's say she works for 10 hours. Okay, and we can just kind of pick a number. If she works for 10 hours, she would make 10 times 23 is $230. 10 hours, $23 an hour, that's $230. So I could go over to 10 and up to about 230, which is, there's 225, so maybe up a little higher than that point. And if I draw a line between those, okay, I could draw a graph. And then from my graph, I could also estimate how much I need to work in order to make $200. So this is my $200 line. If I follow it over, it looks like more than 8, but less than 9. So 8.5, or I would still be safe to work about 9 hours. So the graph also gives us the same information. That's just another way to do it. Another way to solve your problem is to draw a graph. The third way is to use an equation. This is the most accurate method. I think this is a good way to do it because it's faster. And we're always just trying to figure things out right away. An equation, if she makes $23 an hour, an equation for her pay might be something like P equals 23T. Every hour is time, every hour $23. So that could be an equation. The variables don't matter, but that's a good equation to write. We know that Janice wants her earnings to be $200. That means her pay would be $200. Not her time, not her hours. We don't know the hours. We know the pay. So this number here is $200, which is a little backwards. I actually want the pay to be $200. I want the answer to be $200. And then I have 23 times the t. And we can use this equation to discover, are we going to divide or multiply? What do we have to do to find out what t equals? So remember, if these two numbers here are multiplied together, if I want to isolate t, I would have to move the 23 to the left side of the equation. It's multiplying on the right, so on the left, 23 divides. Okay, and if I take 200 and divide it by 23, I get 8.7. So exactly, I know exactly that Janice needs to work 8.7 hours to make $200. Example 2, here's just another quick example. It's asking you, it's showing the cost to rent a canoe. How much would it cost to rent a canoe for each time? So the table tells you after 0 days costs $0, 1 day costs $24, and then it says 3 days cost 72. But you notice the 2 is missing from the table. They didn't put a 2 in the table. So the question is, what about 2 days? How much will it cost if you rent the canoe for 2 days? Okay, there's lots of ways you can do this. You can decide, what's happening in the table, how much does cost go up every time. But I really want the number that's right in here. I know that for 1 day it's $24. Maybe if you think of it that way, 1 day is $24. How much would it be for 2 days then? So 2 times $24, it's $24 a day, should be 48. Okay, so 2 days cost 48. So the number that's missing in there should be a 48 because it goes up $24 every day. 48 plus 24 is 72, so that makes sense. It's going up $48 a day. And then they're asking for 4 days. So that is the number that's missing in here. Well, I know that each day is $24, so 4 days times $24 is $96. So figuring out how much it is for 1 day really helps figure out, doesn't matter the days then, you'll be able to figure it out. If I asked for 100 days, I would multiply 100 times 24. Example 3, last one. At the video arcade, Aaron bought a game card worth a value of $35. Every time he plays a game, $1.40 is deducted from the card. So the very first part A says, write an equation for the value in V dollars of the card after n games. So the value of the card. Please notice it starts off with a value of $35. So that would be our initial value. That's how much the card is worth to start out. Every time you play, you lose $1.40. Right? So if we're going to write an equation based on this, what I want you to really know is that $35 is the initial value. So the formula or the equation would have plus 35 at the end. If every time he plays it's going down $1.40, we could write $1.40n. N is the number of games. But there's one thing missing right now, and that is the fact that it's not going, the card value doesn't go up by $1.40 every time you play. It goes down by $1.40 every time you play a game. So to show that, we would put a minus sign in front of the $1.40 because every time you play a game, you lose $1.40 off your card. So then it says, use the equation to determine how many games Aaron can play before his card runs out. Well, how many games can he play before his card runs out? If his card runs out, the value of the card if it's gone, the value of the card is 0. So if I want to know what happens, how many games have been played if the value of the card is 0, I would put V, I would put 0 in for V. The value is, it's gone. You've used it all. How many games would you have played? We can solve this like an equation. I could move the 35 from the right-hand side of the equation to the left-hand side. If it was a plus 35 on the right, it's a minus 35 on the left. And maybe common sense, you'd be able to figure this out in the first place. If we take away 0 minus 35, that's minus 35. If we take 35 and divide it by $1.40, we get 25. So just to show it, I know that $1.40 and the n are multiplying together. So to move the negative $1.40 to the other side, I would take negative 35 and divide it by negative $1.40. And when I do, I get 25. There are other ways you could have done this. You didn't have to use the equation. You know that how many $40s would go into $35 is kind of what you're thinking. We take 35 and divide it by $1.40, and you get 25. So therefore, Aaron can play 25 games until his card runs out. So we're trying to write equations from situations that you're given. These are linear equations, and you're just given some information in a situation, and we try and get equations from that information. And when you do, the equations help you solve problems.